Good morning. Welcome to Vegas and welcome to reInvent 2016. Just a quick show of hands. How many of you were here last year or have attended reInvent in the past? Okay, so that's good. Looks like we have a bunch of the room that's actually attending for the first time. So just a piece of advice. This conference is slightly different than perhaps other conferences that you may have attended in the past, in that this tends to be a little bit more sessions, lots of knowledge sharing, lots of lessons that you get to hear from customers as well as AWS experts up here on stage. There are over 400 sessions scheduled. I'm sure you guys went through the schedule planner and tried to pick the sessions that you most wanted to attend. But bulk of the sessions, I would say majority of the sessions are being recorded. They'll be made available later on. So don't worry about missing a session. The other thing I want to do is kick off this session. I forgot to mention my name, Sri Ilaprolu. I lead our IoT practice globally for public sector. My purpose here on stage today is actually just to introduce our customers that are going to be talking about some amazing things that they're doing using technology and how they're saving lives and impacting lives in a positive way. I'll introduce Kristen. She's a senior product manager from Thorn. And actually, I won't steal her thunder. She'll go through in detail a product called Spotlight and how that product is leveraging technology and in return helping protect children in the wild. And then Paul is going to come up next. Paul is from ShotSpotter. He's a senior vice president for products and technology. And ShotSpotter is a unique solution in that it uses sensor technology and uses acoustic sensor technology to detect gunshot firings in cities so that you can triangulate and get down to where the problem is. Both of these solutions are a little bit unique because typically when you talk about cloud and when you think about cloud and workloads on cloud, you immediately think about back-end systems, websites, and so on. So this session is unique in that we're actually talking about technology and solutions that are positively impacting lives and saving lives. So without any further ado, let me go ahead and bring Kristen up here.
Okay, can you guys hear me? Okay, great. Thanks for the intro. I'm going to be talking about Spotlight, which is our application that we've built. We're using machine learning and natural language processing to combat human trafficking, specifically sex trafficking. And don't worry, we've sanitized all of this, so you're not going to see things that you shouldn't be seeing. But it's an interesting problem to address with technology. And before we get started, I'll share a little bit about who we are. Our nonprofit organization is called Thorn, and our sole purpose is to drive technical innovation to fight the sexual exploitation of children. So we work with technology organizations, for example, Amazon, Facebook, Twilio, Instagram. We also work with law enforcement and other non-government organizations. We try and make online environments a hostile place if they are sharing child sexual abuse material, as an example. So we'll work with some of our technology organizations to look at what their terms and conditions are. They have child safety protection teams, so we work with them to try and understand what is that ecosystem. Are there any things that we can do to help identify? We also conduct our own research. Sextortion is another one that we've recently, if you go on our website, you can download the paper on sextortion, but we provide that information and that studies back to our tech partners so they can look for patterns of grooming. And then we also want to deter predatory behavior. So when we find out that people are actually trying to search for child sexual abuse material online, we have a deterrence program where we're trying to get them connected to services and help. So there's a variety of things that we do. We're going to talk about one of the applications that we have right now, which is called Spotlight, and why it was created. So we conducted a survivor study in 2012. What we found out was that 75% of the juveniles that had been sex trafficked were bought or sold online. So we knew at that point that there was some type of digital footprint that was out there. We also know in the United States alone, there's more than 200,000 sex classifieds ads posted on a daily basis. The other thing that we know from law enforcement, if I don't know if any of you guys have worked in law enforcement or with law enforcement, is that they have a lot of different things to do. So they might be working on a burglary, as an example. There aren't a lot of teams that actually focus just solely on sex trafficking. And if you think about this massive amount of data in your little town or your little area, are you really going to be able to focus your time, effort, and energy in going on one of these classified sites and really trying to investigate? And what we found is they don't have the time to do that, and it's really an impossible feat given as much data as there is. So what we wanted to do was to provide law enforcement with a tool to be able to provide leads about suspected human trafficking networks in order to be able to identify victims and get them connected to resources. And that's why we created our application Spotlight. And so what Spotlight is, we worked with our partner Digital Reasoning. It's a cognitive computing platform, and we're also using natural language processing. But we're ingesting ads on a daily basis across the United States, and we're showing law enforcement the relationships between those ads. And we'll talk a little bit about what we're doing and the types of tools that we're able to provide for law enforcement. So this graph gives you an example. There's a variety of different sites that we have listed up here. So are you guys familiar with Backpage.com? You can buy and sell a lot of different things on there, but there's also sex classifieds. It is the largest provider. You'll see it's the top line up there. We're also collecting ads from and comments from John boards, a variety of different places. What you see this purple spike is, I don't know if you guys heard, but the CEO of Backpage.com got arrested probably about 2 or 3 weeks ago. There's a California statute that says if you profit off of sexual exploitation that you can be arrested. And previously you used to be able to, you had to pay for your ads on Backpage. Now you don't have to pay. So these charges are from a long time ago, but you can see all the comments on the John boards because they're worried about where the traffic is actually going to wind up going, which is kind of an interesting piece. So what is the data that we're looking at? So we're ingesting probably close to about 200,000 ads on a daily basis. And you can see, I know this is probably a little bit of an eye chart, but you're going to see information about the author, the body, the city. So we have structured data, and then we also have unstructured data. So some of the unstructured data that we're looking at are things like the actual posting, right? So the information about what they're actually selling. There's also free-form information. So there's 2 types of locations. One is the location that you have to select from a drop-down field on one of these sites. And then the other is a free-form field. You'll notice in this one it says, I think it says the Strip. Yeah, so reported location, that's a free-form field. It says Las Vegas Strip. We'll walk through kind of what we're doing with that, but it gives you a sense of the type of information. The other information that we're also processing are images. So we wanted to give you a sense of how we're actually ingesting and processing this. So we do have a third-party provider who's actually collecting this information from open forum sites. And then we're taking and we're splitting up the photos and the forums into 2 different S3 buckets. We're listening for traffic, and then we're queuing it off. Data Jetway is our transformation layer. And then it's DR stands for Digital Reasoning XML, and then we're processing with core analytics. So some of the core analytics, and I'll talk about this in a little bit, we're using our natural language processing, so we're doing phone decoding, and I'll show you that. We're also using language flags, and I'll talk about that as well to understand, is somebody under the control of a pimp? And then we're also doing our image processing, which I'll also share about that. And then we move more for global analytics, where we're looking at the networks. If somebody has been trafficked across state lines, which we'd call the interstate flag. And then also our alerting mechanisms. We allow law enforcement to get alerted on particular criteria that they're utilizing. Elasticsearch is really more of where our persistent data is being stored. And then we've got a web API, which law enforcement is able to actually access the application. So if you can think about it as basically, it's law enforcement's search tool in investigating human trafficking. This is even probably harder to read. But it goes through the same process. We've got our load balancer. And then as far as what's stored in SQL is primarily, again, our alerts and what law enforcement actually saves as far as their criteria that they want to look at. So I wanted to talk through kind of the deconstruction of a sex trafficking ad. Again, we've sanitized a lot of this, so hopefully none of this is offensive to you. But what you have is anything that you would typically have in any regular type of posting, right? If you were going to sell a couch as an example. But you have your title, you have your tagline, you've got your ad copy details, and then you've got what we would call all of this metadata over here on the right-hand side. So you've got your post ID, when it was we actually collected that data. And we don't have, in this case, we don't have a post date, phone number, age if they've indicated age, and then you'll see multiple locations. The first location that you see is that database field from that primary source, and then any secondary, tertiary locations are free-form fields, and then an actual source. So if that ad is still up on that source page, we'll allow law enforcement to go and click on that. So one of the first things that we're doing from a natural language processing perspective is when you're investigating sex trafficking, one of the things that they will try and do is obfuscate their phone number. So you'll notice here that they'll spell out the words, they'll put spaces, they may even put emojis in between there. And one of the first things that we're doing is we're stripping all of that out and we're standardizing and normalizing that. Why is that important? That's important because if law enforcement gets a tip that there's a runaway and they have a phone number, they have no idea what it looks like in its obfuscated form, right? They need to have it in a standardized format which they can input and search and then bring up the results within Spotlight. This is one of the most critical pieces of information in an investigation. Not to mention, this is also how you would communicate somebody if you were setting up an operation, right? So the other thing that we're doing is we're processing images. And you'll notice that these images look slightly different, but they actually look somewhat similar. Some of the challenges is that they will crop images, they'll put watermarks on them, and they will come up as a different hash. We're hashing them with an MD5 hash, but we do allow law enforcement to pivot off of an image and to be able to conduct a search based on that exact match search. So they can actually click on an image and actually see what are the other ads that are showing up with that image. And the reason why that's important is that you guys may have had your phone numbers for a very long time, but in this space, they're using burner phone numbers, but they're often using the same or very similar pictures. And so if we can allow law enforcement to utilize that image search, then they can potentially find a new phone number that they might be utilizing in an investigation. So one of the other things that we're doing with the machine learning is we're flagging ads. So as we ingest these ads, one of the first things that we did before we developed Spotlight was sit down with law enforcement to understand how do you actually conduct your investigations? What are those risk profiles that you're looking for? And so we came up with 5 of them. One is massage, and that's typically going to have information about specific hours, information about discrete parking. Control is going to be indicative that somebody's under the actual control of a pimp. So they might have something like a pimp crown, and they may have particular things that you can or cannot do, for example, in a posting. An immature would have language in it. This is based on the true set that we have from law enforcement of 100 known juvenile cases, in which there might be some copy or some text, for example, that says playful, young, open-minded. It doesn't necessarily mean that if it's flagged as immature, that it necessarily is a juvenile, but it's indicative of the patterns and behaviors that they have seen. And then interstate is something that is primarily really just a hard and fast rule in the sense that we've seen a posting happening in one state, and now it's also happened in another. So they can see a pattern or a circuit that's happening with the trafficking that's occurring. Oh, I put control on there twice. The one that's supposed to be on the very right is escort. So escorts can indicate that there's, they typically have more professional sounding postings. They might actually be a licensed escort agency in a particular location. But again, what this allows law enforcement to do, depending upon what type of investigation or what type of profile that they're looking at, it allows them to actually build their search criteria and put filters in there, right? Again, our mission is really from the juvenile perspective. So if they want, they can indicate that I want the immature flag in my particular location. And I can even indicate specific keywords. For example, two-girl special is something that is somewhat indicative of minors, or something, for example, in an event, new to town. So they have all these different aspects at their disposal. We weren't really able to show you a lot in the application just because of the explicit nature of what we're doing, so I blocked out some things. But what you're seeing is our ability to map through space and time related ads to an original ad. So you'll notice there's a map on the right-hand side. There's these red dots with numbers around them, and that's indicating the frequency of ads that are associated in those particular locations. So again, it allows law enforcement to really understand what's happening. And again, when you think about jurisdictions and who's working on a particular case, this is really helpful. It's also helpful from a prosecution perspective. So they can kind of understand what the full span of this actually looks like. This next slide demonstrates our ability to show the intelligence that we have. So again, one of the challenges that law enforcement has is it's a massive amount of data. They don't know what they don't know. And I'll show you a picture of how investigators were doing sex trafficking investigations before the use of Spotlight, and it's jaw-dropping when you're working in a technology space. But what we're trying to do with what we call our network graph is show the relationship between the data elements that we have. In this particular graph, at the center, you're going to see a phone number, and then you see the post IDs that are circuiting around it, and then you also see in gold, then you see the numbers. So that's the frequency of that pattern of that phone number and that post ID. Post IDs are reused, and so are phone numbers, and then we can step it out based on the number of relationships. And again, this can help law enforcement uncover new phone numbers that they didn't previously know existed in a particular case. One of the other things that we're working on is going mobile. You can think about this if you're law enforcement, if you have a particular operation and you're working on a case. One of the first things you do is you kind of look at all these profiles. Who is it that I want to arrange a date with to try and get in and really understand what is happening? And so being able to access it via mobile is really critical. We allow law enforcement to create alerts, which is what you see on the very right-hand side. So you can create an alert based on particular parameters that are within a posting. So an example might be for a particular phone number. And then you will get an email notification anytime that a new posting comes into play with that particular phone number. And that's been a huge time saving for law enforcement. One of the other things that we found out after we had deployed Spotlight that law enforcement really likes to utilize Spotlight for is that these ads actually are falling down anywhere between, it can be an hour after they're posted or 6 days. And so their evidence is basically deteriorating. We've had Spotlight up since October of 2014, and it really enables them to understand how long somebody has been trafficked and the full scope of that actual trafficking that's occurring. Which brings me to my next slide, which is really the data assets. In this world of investigating sex trafficking, the data is changing constantly, right? There are different phone numbers, there's different post IDs, there's different photos. Again, we're ingesting probably more than 150,000 ads a day. We have over 65 million ads in Spotlight. We've been up since October of 2014. We have over 400 million images in Spotlight. That's not deduped, so just want to clarify that. That's another challenge we have. So to give you a sense, we have over 3,200 law enforcement that are utilizing Spotlight. We're in all 50 states, including DC as well. We'll be expanding into Canada at the end of this year. We have over 850 federal, state, and local agencies that are utilizing Spotlight. And we are a nonprofit, and because we are mission-driven, we do provide this application free to law enforcement. And to get a sense of the type of impact that Spotlight has had, this is based on the last 12 months, based on our September 2016 survey. We received a 25% response rate, so we even know that the impact here that we're going to tell you about is low. But Spotlight is averaging about being able to help law enforcement identify kids, on average 5 kids a day, assisted in over 7,442 trafficking investigations, a total of 6,325 victims being identified, and close to 2,000 children, which again is our sweet spot. And then the adult victims, over 4,345. And then the traffickers or the pimps, 2,186. So it's pretty significant. So we talk about the technical approach to this. And if you look at what investigators were utilizing beforehand, you'll see on the left-hand side, there's date columns, and there's a whole bunch of phone numbers, and then you start seeing arrows. This is literally an investigator. What they would do, they would go on to Backpage, and they would start writing down things that they think might be related. This is not how you can tackle this problem at scale, right? And then we know based on our survey, for those law enforcement who are coming in on a daily basis, they're saving 60% of their investigation time because they have all of this information. We can show the relationships that are there. So it's been a really significant time savings for law enforcement. And you won't probably read all of these, but we've gotten a lot of feedback from law enforcement about the magnitude that it's been able to help from gathering intelligence, plotting their trends, and allocating resources when they're having investigations. The second one is, it's pretty, I guess it's tough to read, but it shows you the impact that Spotlight was able to provide law enforcement with one of the only leads that they were able to have for a John who had raped a minor. So it has a huge impact. We're really proud of what we've built and where we've come from. And we're looking forward to continuing to build on how we can do similarity image searches. So if law enforcement has an image that they received from a parent, as an example, for a runaway, that we can hit it up on with our images. So there's lots of different things that we think we can continue to do to help improve the efficiency and help identify people who are being trafficked. I have my business card here. If you're interested, you can feel free to take a picture of that. Because now Paul is going to come. And I think after we're both done, we'll be taking questions. So if you have questions, maybe write them down.
Thank you. So, good morning. My name is Paul Ames, and as Sri said, I head up the technology team for a company called SST. So SST is a small company based in the San Francisco Bay Area. We're about 65 people large. We're VC backed, and we have 2 lines of business. The line of business I'm going to talk about today is public safety focused, and that's the ShotSpotter product or service. We also have a security focus, and the goal there is to build and deploy effectively an alarm for active shooter scenarios. So ShotSpotter is an acoustic surveillance system, and so the goal of ShotSpotter is to drive down and prevent gun violence. At its highest level, we detect gunshots that occur in a community. We locate the precise location of that gunshot, and we alert so that the cops know where the gunshot is. So our customers are the police agencies and the cities. So we have roughly 90 customers. The majority of them are based in the US, although we do have a couple of customers in South America and South Africa. So at a high level, we deploy acoustic sensors to the community. The sensors listen for sounds that could be a gunshot, When 3 or more sensors hear the same sound, we run information or metadata relating to the audio through machine classification, through a location algorithm, and through human classification. And then we publish that data to the cops. And we do that within 30 to 45 seconds from the time that somebody pulls the trigger. So ShotSpotter is offered as a service. We price the service according to square miles covered. Our largest customer is New York City, and we have roughly, I think, 60 square miles of coverage across all of the boroughs in New York City. So although the technology is incredibly fantastic, it does nothing on its own. It's the police agency that are using that information to help drive down gun violence. So a lot of what we do as a company is partner with the police agency to develop and roll out best practices to maximize our chances of reducing the number of gunshot incidents that are occurring. So I'm going to just give you an idea as to some of the scale of the gun violence problem, particularly in the US, talk a little bit about the technology, and then talk about our engagement with AWS. Gun violence is incredibly underreported. Each police agency reports gun violence in the form of homicides to the FBI. So when you look at those numbers, you would think that that would give you a rough idea as to the amount of gun violence that's occurring in a community. The reality is it doesn't. So when we deploy a system to a community, we know how many gunshot incidents are actually occurring. And we're able to find over and over again that for every homicide, there are about 100 gunshot incidents that occur in a community. Second, this is kind of surprising, I think. In the communities that we serve, the number of gunshot incidents that are actually called in to 911 dispatch are only between 10 and 20% of the ones that actually occur in the community. So why is that? It's because gun violence in these communities has become normalized. It's just part of everyday life. The police agencies that we work with tell us that the number of gunshots, or rather the majority of gunshots, come from a very small number of shooters, serial shooters within a community. So you're talking roughly 10 to 15 serial shooters that are making or creating most of the mayhem. So this is kind of good news, because if you take one of those shooters off of the street, it's going to have an immediate direct impact. But it also serves as a secondary impact because shooters don't want to get caught. And so it serves as a deterrent. So for communities in the US that don't have ShotSpotter, what's happening is gunshots are fired. The people in the community are not calling the gunshots in. The police don't know about it. They're not responding. And the overall effect is the people in the community believe that the cops don't care about what's happening in their community. Obviously a bad situation, even if the people in the community know who the serial shooters are, they're not going to tell the cops because there is no trust. In cities that deploy ShotSpotter, that are following best practices, each and every gunshot incident results in a cop being dispatched to the precise location of the gunshot. The cop is going to conduct basic investigative techniques. They're going to look for evidence. Particularly, they're going to look for shell casings. Shell casings allow the cops to relate crimes together. They're going to get out of the car. They're going to interview people. And perhaps more importantly, they're going to knock on the door of the people in the local community and say, how are you? You know, we know that there was a gunshot that just occurred. Are you safe? Over time, with consistent response to gunshots in the community, the people start to build up trust. And with trust, they're more likely to share information with the cops. And they're more likely to self-police. So what we find is in communities where we deploy ShotSpotter, the incidence of gunshots go down by about 35% over 2 years, which is pretty significant. Just to give you an idea, a typical community has roughly somewhere between 500 and 1,000 gunshot incidents per square mile per year. And there are many communities in the US where that number is way, way, way north of that. So I mentioned earlier that we deploy acoustic sensors in the cities that we cover. The sensors are deployed at a density of roughly 15 to 20 sensors per square mile. The actual sensor itself is a device that we design. It has on board a cellular wireless to communicate with the cloud. It has a couple of microphones on it, just the regular microphones, nothing sophisticated that you would find on a cell phone. And most importantly, it has a GPS chip. And so the GPS chip tells us two things. One is precisely where that sensor is located, and we need that to calculate the location of the gunshot. But more importantly, the GPS network gives us a very precise synchronized clock down to somewhere in the region of 10 to 15 nanoseconds. So that's kind of the key for figuring out where a gunshot comes from. So when somebody shoots a gun, the sound emanates from where the gunshot is. The sensors pick up this impulsive sound. But most importantly, they're picking up the sound at different times, and they're time stamping that pulse with the GPS clock. So it's very precisely timed. The next thing the sensor does is to perform some analysis on the waveform, and it turns it into a set of features that describe the waveform. Those features are then sent back to the cloud, and we take those features, we run them through a machine learning classifier to say, is it a gunshot, is it not a gunshot? We use the precise time of arrival of the audio at the sensors to calculate the location. We then send an audio snippet, the precise location, the machine classifier decision to a human reviewer, and it's the human reviewer that performs the final assessment as to whether or not it's a gunshot. They press a button that is dispatched directly or sent directly to 911 dispatch, and also to the cops that are on patrol. And again, remember that that's done within 15 to 45 seconds. So this is kind of a cool chart, I think. On the right-hand side is an area of a city that's roughly, or a little less than a square mile. The diamonds that are on that chart are the locations of the physical sensors. So what we're doing, we use a navigation technique called multilateration. It's kind of like Shri said, triangulation. But what we're doing is pairs of sensors, or we're taking pairs of sensors, and we're taking the time of arrival of pairs of sensors and plotting all possible points at which that audio could have come from. And so that's what you see on that chart. You see a bunch of hyperbole, and it's the intersection of those hyperbole that is the location of the gunshot. So conceptually, fairly straightforward. On the left-hand side, you see 3 different waveforms that come from sensors that are different distances. This particular incident is a 4-round incident. So I'll just play, just to give you an idea as to what a sensor actually hears. So this one is, I can't see, it's around about 200. Sounds kind of interesting. You can hear the 4 shots. You can also hear some background noise. In this case, it's wind. This sensor is further away. Actually, if you look at the waveform is more identifiable as 4 separate shots. And the last one, a little difficult to hear, but there's a lot more noise there, and there's also a fair amount of echo. So one of the challenges that we deal with when dealing with an acoustic surveillance system in a city is there's a lot of noise. There's a lot of buildings. So the audio that we receive is not as beautiful as you would imagine. Okay. This is I'll call it a architectural view of our system as it was at the beginning of the year. At the bottom, we have sensors. We store the pulse data in relational databases. We have servers that perform location, machine classification. We have a 24/7 human classification team on site. And we have an incident publisher that publishes to customer endpoints, the green things along the top. I'll just point out a notification API on the right-hand side. A lot of our agencies take the raw data that we supply and deliver that to video management systems so that they can correlate gunshots to video surveillance. So SST originally deployed ShotSpotter as a customer premises deployed software sale. Around about 6 years ago, we made the decision to move to offering it as a service. 6 years ago, the public cloud offerings that were available were very different than they are today. The decision was made to build out our own private cloud. So we have built out 2 separate colos, one on the West Coast, one on the East Coast. We use commodity Intel x86 machines and VMware virtualization. Just taking a quicker look at, or a step out from the colos, on the right-hand side you see the clusters of sensors. They're communicating with the colos over the mobile network, the mobile carriers M2M networks. On the left-hand side, you see the customer endpoints communicating with the colos over the public internet. So this private cloud has served us pretty well over the last 6 years, but there are 3 issues that we want to address over time. First issue is that from an IT perspective, this is a pretty significant commitment or ongoing commitment. Second, over the last couple of years, the growth of the company has really accelerated. So we're adding new cities. We're adding additional miles to existing cities. So we're growing horizontally, and it's a great problem to have, but it's beginning to get to be a bit of an issue. So that's a problem we would like to solve. The third issue we have is unique to having a acoustic surveillance system. So 2 times a year, there are significant impulsive events in cities on New Year's Eve and July 4th. People let off a whole bunch of fireworks. So what we see is a 2 order of magnitude increase in pulses being processed through our colos. So as a consequence, we have to size our colos according to the high water mark, which is kind of an expensive proposition. Of course, what we want to be able to do is scale up prior to July 4th and then scale back down afterwards. Not surprisingly, that's why it was that we started talking with our friends at AWS. So our initial conversations with the AWS team were really all centered about what could we do to solve this vertical scaling problem that we had. So we piloted let's do a lift and shift strategy. Let's take what we've got in our colo, stick it into the AWS Cloud, and see how well it works. Not surprisingly, it worked fine. But because of some architectural decisions that we made a few years ago, it really doesn't fit that well into the AWS Cloud. So as we were having these conversations, we were also, at the beginning of the year, developing a mobile application, and that proved to be the stimulus that we needed to move something to AWS. So we built a new application. The back end for that mobile application was entirely built out in AWS. The application went live in, I think, August of this year. We've been extremely happy with both the application, but also what we've been able to get out of AWS. I think there was something else I was going to say, but I can't remember what it was. That's fine. I guess, actually, let me just go back. The interesting thing, I think, is that we've kind of accidentally come across an approach that I would suggest to some people in the audience might be something you want to think about. It's a lot easier to adopt AWS for a new application than it is to consider taking, I'll call it legacy architecture, and moving it into the cloud. So the learnings that we have gained from working with AWS, building out this backend, are going to be directly applicable to the backend for our location of the ShotSpotter service. So what we'll be doing in 2017 is focusing on getting that done, and particularly working with Shri and his team on the IoT offerings. Here's the mobile application that we built out. It was targeted at one use case, what we call internally as getting the cop to the dot. So on the left-hand side, you see a list of gunshot incidents. In the middle, you see those same gunshot incidents plotted on a map. On the right-hand side, you see an individual incident that the cop is responding to. So we at SST really believe in what we're doing. We believe that the technology is helping to drive down gun crime. I haven't talked at all today about the impact on the community of gun violence. It is significant. I would encourage you to search out a podcast that our CEO did last week with TechCrunch that's available as a podcast. Take a listen to it, and it gives you more of a sense of why this is a problem that must be solved. It's not just about people getting killed. It's about the impact on kids in the community. It's just bad stuff. So on that note, I think I'll stop.
Cool. Thank you, Paul.
Yeah.